Hello everyone, today we will be discussing Gc-Ftir, an important analytical technique in chemistry. So our group members consist of Ainatul Imani, Rabiatul Adawiyah, Amanda Sunindai, and Nurhaini. To start, let's break down what the acronym Gc-Ftir stands for. Gc-Ftir stands for Gas Chromatography Fourier Transform Infrared Spectroscopy. It combines two powerful analytical methods, which is GC, gas chromatography, and FTIR, Fourier Transform Infrared Spectroscopy. This means that GC will separate the complex mixtures and the FTIR will provide detailed molecular identification. So GC is a technique used to separate volatile compounds in a mixture. A sample is vaporized and carried by an inert gas known as mobile phase through a column packed with a stationary phase. Compounds separate based on their boiling points and interaction with the stationary phase. While FTIR is a method to obtain an infrared spectrum of absorption, emission, or photoconductivity of a solid, liquid, or gas. Infralight is passed through a sample. The sample absorbs some of the light at characteristic frequencies. A detector measures the transmitted light, and a Fourier transform converts this data into a spectrum.
The interface in Gc-Ftir transfer the separated components from the Gc column to the FTIR without losing resolution. The interference often includes a heated transfer line to keep the compounds in the gaseous phase and to prevent condensation. In data processing, the IR spectra obtained for each compound can be compared to reference spectra in databases for identification. The retention time data from the GC and the spectral data from the FTIR are combined to accurately identify and quantify the compounds in the sample.
This is the schematic diagram. The technique involves cold trapping GC elute by adding 1 to 2% of inert metric gas to the carrier gas. The elute stream is sprayed onto a gold-coated drum at around 10 K, freezing the analyte into a cage of selected molecule, forming metric isolate spot of 200 to 300 nano diameter. This method allows for many hours of storage and post-run scanning, as long as the cryogenic conditions are maintained. Spectra obtained can differ from conventional methods, particularly showing band narrowing effect in the smaller molecule, necessitating spatial reference collection for identification. Here are the basic components. Firstly, gas chromatography. The GC separates the sample into its individual component based on their retention time. It's the first step in this process. Second, interface. This component connect the GC to the Fourier transform infrared spectrometer. It allows the fraction from the GC to enter the FTIR system. Next, Fourier transform infrared spectrometer. The FTIR performs spectral analysis on the fraction from the GC. It detects the interference signal generated when each fraction selectively absorbs modulate infrared light. The FTIR then converts this information into gaseous infrared spectra for each component. Lastly, computer data system. The computer system stores the collected interferogram data and retrieve molecular information about each separate component using a library.
Now, I will be presenting the applications of Gc-Ftir in various industries. First off, in wastewater analysis, Gc-Ftir ensures precise identification of all contaminants, crucial for environmental protection. It aids in monitoring pollutants and ensures regulatory compliance by meeting discharge standards. Additionally, it optimizes treatment processes with detailed chemical composition information. Then, in the petrochemical industry, Gc-Ftir provides a detailed characterization of all components in petroleum products. This helps optimize refining processes and ensures product meet regulatory standards and specifications. Other than that, for other analysis of essential oils, Gc-Ftir accurately identifies all other compounds, maintaining quality and consistency. It assists in product development by creating new fragrances and improving existing ones through detailed chemical analysis. Lastly, in perfume analysis, Gc-Ftir excels at separating complex mixtures of fragrance compounds. It provides precise identification and detailed molecular structure information for each component, crucial for analyzing both volatile and semi-volatile compounds. In summary, Gc-Ftir is a powerful tool across various industries, ensuring precise identification, quality control, and regulatory compliance.